This is Mrs. O'Neill for your Chapter 6 Review Questions and Problems. Again, let's look at the atomic structure of potassium here, and it's showing you the inner shells that are full. Remember, we call these those core electrons, and of course that outer shell or that outer energy level is where those valence electrons are. The only thing I don't like about this is these two first electrons really should be paired up, just like the second energy level. You have 2, 4, 6, 8, and they're kind of paired up. Again, thinking about that orbital filling diagram, right? So not only do the L electrons are on the energy levels, but they kind of are in a certain way, right? They're kind of like grouped together because of those orbital diagrams. So as normal, you're going to go through the video by pausing when you see the question or the problem. Some of them have multiple parts. Again, you can do them mentally or on paper, but I strongly suggest having your calculator and your periodic table, your reference sheets available. You're going to then continue playing the video to look at the solutions or the answers. And again, some of these are going to be above and beyond what you'll see on the test in class. However, they are really, really beneficial to help you prepare for that AP exam. So number 1 is the pickle. And your answer to A, again, there's the equation or formula you should be using. And if we look at your dimensional analysis, your conversion factors, it really doesn't matter which order you did this. If you went from meters to nanometers first, that's fine. And then using your 1 over nanometers in order to cancel out the nanometers to get the hertz or seconds to -1 power. B, again, here I show you dimensional analysis all the way through, but you might have made an equal here because you're kind of multiplying out and then use more conversion factors along the way. So again, that's why I like dimensional analysis, because it really doesn't matter necessarily the order of how you do the problem, as long as, again, at the end of the day, you cancel out the correct units to get the actual unit you want as an answer. Letter C. Again, if you have an equation, great, use it. But if you don't, again, dimensional analysis always is helpful. And letter D, again, not only do you have to know how to do mathematical problems, you have to know how to explain or justify your answers. Number 2, visible elements. This is one, again, you might want to take even a screenshot of this information so that when you see the answers, you'll understand where some of them come from. This is also about the spectrum, so you can either look in the textbook. I don't believe I have it in your packet for AP, but you should have the spectrum in your packet from Honors Chem 1. So hopefully you kept that, or again, you have Google, right? So you can always Google that atomic spectrum in order to answer this question, because you do not have to memorize that. So now let's look at the answers. Here we go. Answer to A. Answer to B, answer to C, and number 3, unpaired electrons. Remember, we talked about the condensed electron configuration, but also how important it is about those unpaired electrons, because those are the ones that are going to react with other elements. So again, pause and use your periodic table, count up those electrons. And hopefully you took the time to write these out. And again, coming up with those, how many are unpaired, is going to help us understand how it's going to react with other elements. And I also believe we did this either in the bookwork or on a worksheet, electron configuration, and talked about those paired versus unpaired electrons. Again, thinking about that orbital diagram. Number 4, about uranium isotopes, and no need to look in your book for figure 6.31. It's right here. So I I color coordinated. I apologize for those of you who might be colorblind, but for letter C, you're going to use this uranium box up here, and for letter E, you're going to use this thallium box over here. All right, so hopefully you paused. Hopefully you remembered that because these are isotopes, the one thing that that is different is the masses, and that's what those numbers represent, right? The high number is the mass number that will be different between different isotopes. And also letter D. Letter D is a little bit above and beyond. So if you're kind of confused about letter D, that's okay. That's one of those above and beyonds, and I'll explain that when we get there. So here's your answer to A. This should be pretty simple. However, I have seen almost in every single AP exam, there's at least one question, usually it's multiple choice, about electrons, protons, and neutrons. Letter B. So again, make sure to just count those electrons because the location of uranium is different depending on the different periodic table you use. But again, use the one that I gave you for your reference sheets. Letter C, again, is dealing with how it compares to the electron configuration from this figure in the book. So hopefully that makes sense. Letter D, again, that above and beyond. So we're going from uranium to thallium. So what do we have and what do we need to lose in order to get there? And so that's this equation. So if we are losing 2 protons, and again, if you go by protons, protons are never ever going to change. So if you know the number of protons, that is your element. So the only element that has 2 protons is helium, and then the rest makes sense. If it has an atomic number of 2, that would have 2 protons, 2 electrons, and the atomic mass is 4, so subtract them, get 2 neutrons. So that should make sense when you're going from uranium to thallium. As long as they give you this information, you should be able to figure out how many protons are left over, and that would be the element that's also taken away. And your letter E, again, you had to use that box. So hopefully that makes sense, or again, giving you that extra information. All right, hopefully you're ready for your test. See you in class.